Bismillahirrahmanirrahim. In this video, I'll be calculating a yield curve out of NS Nelson-Siegel model, which is mostly used by banks um, for estimating the yields on different, loans, bonds, etc. And calculating yield curve is not a straightforward procedure because it depends on the market and the policy rate by the central banks. And central banks also use this NS model mostly to estimate the yield curves to offer the customers, the investors, an appropriate discount rate. So there is also another problem. We know that a price of the bond is given by a summation of cash and discounted by some discount factor. So this is the price of the bond. So one can easily understand that, okay, if you don't know the discount rate, you want to know the discount rate came out of the prices that investors have offered on the auction. So with the different maturities, we can get different discounts. But the problem with the auctions is practically, for example, if there is a 5-year bond, some investors have offered 98, some investors have offered 98.5, and there is also a window of special of the auction, without auction prices whose discount is relatively low. So there could be, that could be, I would say, 99.5. So in that scenario, it's not straightforward possible for us to find the discount rate because there will be multiple bonds for the same maturity. This factor is highlighted in the term structure of interest rate presentation, that given the prices, what will be the yield on bond depends on many factors such as maturity and timing, and magnitude of the cash flows, and inconsistent pricing, especially hence several bonds with the same maturity. So what I'll be doing is I'll be using this formula to compute a yield curve, and using these bonds to calculate first my uh, estimate the yields to the regression. Then I will compute NS model, and then I'll be using some solver to estimate the appropriate alphas and betas which are used in this model: alpha 1, alpha 2, alpha 3, and beta. So these four parameters I need to find out, then I can draw a curve out of this. So coming straight to the problem and solving it, that how we can do this. So we can see here that we have 15 bonds with maturity. With these bonds have the same maturity with different coupon rate, obviously different prices. These two bonds, same maturity, different prices, and these two bonds with the different prices. So how we can find out the discount rates out of these, the YTM, yield to maturity of these bonds. So let's start with this maturity. First I have to draw the cash flow out of these bonds. Time 0, 1, 2. Maximum maturity is 12 years. These are annual coupon bonds, you can say. Assume price is this initial cash outflow. Right. So the cash flows, the metrics for the cash flow would be computed logic. If this thing is less than its maturity, then obviously the coupon payment would be given. Right. If not, this thing is equal to this, this, then the value should be 100 into 1 plus this, the decimal should be 0 if it's false. Right, so that's okay. Double check it's okay. So first bond with 1 year to mature will pay out a cash of 102. Actually, I want this to be same. Lock this, lock this, and log these, log these, log this number and number. Right, and okay, I think it works. So control C. Yes, we can get the cash flow out of these. Double check for any bond. For example, this bond maturity is 8 years. 1 to coupon at 5%, 5.5%, and 8 year it pays 105. This bond 6 year maturity. At 6 year it pays right 4.5 and 4.2%. Double check this 9 year bond. Right, in the 9th year it pays out. So cash flow is right. Next, we're gonna be finding a discount rate for this. So in order to find the discount rate, I'll be using regression. If you know the regression form of the matrix, it would be like this. Here we have price is equal to in regression form, price is equal to C D. Then D can be find out by C transport, C inverse, and C transpose into P. Then we can get the discount vector of discounts. So for using this formula in this column is a matrix. So I'm expecting 12 by 1 matrix. I'll do that later on. M malt, M inverse, malt, transpose, this cash. I don't know if we're doing right or not. I'll find out soon. then I have to again this, bracket close. So this is the argument for the m inverse, bracket, which one is it, right, bracket. Now this are close of the first argument. The second argument, m mult transpose. Oh, I'm making a mistake actually here. I should be correcting this afterwards. Price. I should be using negative or positive. I should be using positive. Right. The mistake I am making is this is I5 dash 9. So I and should be H. Okay. Now that looks fine now to me. Control Shift Enter. It works. Okay, is it okay? So these are the discount factors. So once I got the discount factors, the next thing I need to find the yield. Now how I be gonna be finding the yield is taking the log of actually. So as we know that a discount is 1/1 plus y kind of thing, or if I take imagine that this is continuous compounding, then some e would be there. So what I'll be doing is I'll be taking log of my discount factor and divide by then time. So in this way, yeah, you can work out with this later on. It's quite simple. Find this whole thing in any time value of money chapter. So regression yield is given as ln of this divided by maturity, right? Negative sign is there, mind this. So these are the yield weights as determined by the regression. So see how the regression solved the problem of multiple bonds with the same maturity. The next is I need to find NS weights, NS yield. Okay, NS yield depends on what? Alpha 1, alpha alpha 1, alpha 2, alpha 3, beta, and there will be some error, right? And there will be some alpha 1 plus alpha 2. Okay, so ns yield is given by this formula. So instead of writing the whole formula, it's complicated in Excel. I mean, you have to work out with many brackets. But what I've done is I have developed a homemade ns formula in Excel using VBA, which is ns weight, and the input of this formula is alpha 1, this, and kind of things. So let's imagine put some arbitrary numbers in this. Put 0.1 here, minus 0.5, 0.5 here, 0.1, let's say 3 here, and beta should be it should be more than 1. So that's a condition, and error is I'll find out later on. So this is given in this equations: alpha 1, alpha 2, alpha 3, and beta. So ns weight, this, then this, then this, then this. Then there will be another factor, time, right? So time is 1. And I would also like to log these numbers. This has come all, and I want to reduce the difference between the two. Right, so this error is quite big. If I look at 0.43, this should be minimum. I'll make use of solver to reduce this. This thing should be minimum by changing what cells, changing these things, and I have a constraint that beta should be positive. I've got a solution here. So these are this is error has gone to way go on to 0 actually, and these are my yield rates as per ns method. If I want to see the graph, the fitting of the graph as per the yield curve, paste as per value, and maturity here. Change the axis, start from 0.1. So you see the regression result and the NS yield curve quite smooth as we want to see in the textbooks. Okay.